Okay, good morning from here in London. Thank you for joining us for today's Siemens Global webinar. Today's topic will be looking at overcoming aerospace supply chains product development challenges. I'm delighted to welcome as our speakers today Mr. Chad Jackson and Mr. David Chadwick. As you can see, their bios are up on the screen. I'll be very brief. I'll just pick out a few points and then we will be underway. Chad is a research analyst, he's a publisher and a thought leader, and he provides insights on technology-led engineering initiatives. He is a prolific writer and has published educational thought leadership topics hundreds of times, and he's a much sought-after speaker, and we are more than delighted to have him here as one of our guests. And following up from Chad, David is responsible for industry-focused and capability-focused sales campaigns for Solid Edge. He has well over 30 years of application engineering, project management, and marketing experience, and he has been responsible for many successful product data management implementations within small, medium-sized manufacturing organizations, both globally and locally. Okay, so we're delighted to welcome David as well. So without further ado, I'd like to hand over to your first speaker today, Mr. Chad Jackson.
You know, the trends that are kind of occurring in the aerospace industry it's timely to have this type of discussion. So yeah, let me dive right in. So if you look at the industry, there's a number of trends that are really driving aerospace suppliers to do things differently. And one of those is, you know, in a lot of countries, when you look at defense spending, obviously it depends on where you are in the world, but there is, in general, less funding for it. And this is driving some really interesting, I guess, an interesting dynamic. You know, with fewer programs, defense programs, development programs, and often those programs have less funds for development overall. There is more competition between suppliers, not only at the top level, but all the way down the supply chain. So a lot of aerospace suppliers are having to be more aggressive with their bids, meaning they're having to be not only, you know, a little bit lower with their pricing in an effort to compete, but also kind of commit to product requirements that are more stringent and commit to schedules that are tighter. So all this plays into a dynamic where these programs that suppliers are participating in are more demanding, and these organizations have to get better at what they're doing, especially with development, in order to turn a profit, frankly. So that's one trend. Another trend is that, you know, in the past, further down the supply chain, and even Tier 1 and Tier 2 suppliers, they were often focused on delivering components. And what you're seeing today is that prime contractors and even defense organizations are pushing more and more systems out to the suppliers. And that is then getting pushed down the supply chain. So the complexity of the stuff that is being developed in these programs is increasing. So not only are the requirements more stringent, the schedules are getting tighter, but the stuff that's being developed is actually getting more complex. So that's another dynamic, excuse me, and then there are more regulations. Around the world, you know, obviously this is going to vary depending on the region of the world that you're in, but in general, there are more stringent regulations that must be complied with for these programs. So overall, this makes for a pretty challenging, you know, environment to be an aerospace supplier. So now, when you look at digitalization, and this is really interesting because this term is being used in the industry, but I haven't seen a whole lot of good definitions around it. So let's take a step back and do that right now. So there's two main components of digitalization. One is getting a complete digital definition of your product. Okay, so this covers, not only does this cover, all the engineering disciplines that you see here. Software has a role to play there as well, but requirements, which you could say, in some cases, it might be separate from the digital definition of the product. It's kind of like the set of constraints that the design must act as a solution for. But having a complete digital definition of your product allows you to have a single source of the truth. So when different engineers from different domains and even other systems need to understand the context of a product. They need to understand what the product is so they can make a good decision. Having a single source of that digital definition removes ambiguity. So it allows you to make better decisions. It removes error in the development process. Now, this is complemented by a digitally run, digitally executed, and digitally automated development process. And this includes procedures and stuff like that. So this goes from very simple things like routings and tasks and approvals. This gets into more complex things like design release, change management, regulatory compliance. And there's a synergy with the digital definition for the product. So the digital definition of the product is used in the processes and procedures that are digital. And then the digital processes and procedures, actually, you can kind of think of them as evolving, maturing, modifying that digital definition. So during the course of a design cycle or during the course of a change process, you're actually going to be adding more content. You're going to be offering more depth with that digital definition. So this is the scope of the digitalization process. You have the digital definition on the left. You have digital processes that are executed and run on the right. Now, these concepts of digitalization can be applied in many different phases of development. It's not just design. So you can apply it to costing, pricing, and quoting. You can accelerate it. You can use it to gain more surety and confidence around the cost that will be incurred with the project, so you can bid more aggressively for something we just talked through with the industry trends. When you look at concept design and architecture, getting this right up front is really crucial. The decisions that you make early on can have a dramatic effect on ultimately the profitability of the project for the company. So being able to assess lots of concepts, doing your due diligence, following processes and procedures, and validating that you have done so is really, really important and powerful. Detailed design and verification and validation, this is what many people associate these efforts around. Getting, as you're designing things, capturing that as part of the digital thread and having an audit trail of how the digital definition evolved, and using digital processes for verification and validation to make sure that requirements are satisfied, to make sure that performance is as you expected. And then manufacturing planning and preparation. So using digital definitions and processes is powerful here too. So this, you can make sure that your production efforts actually match what you expect. So it's not a big surprise. So you're not caught off guard. I guess that's the better way to phrase it. So digitalization has an important part to play across all of these phases. Now, we're going to be diving into, in this webinar, detailed design and verification and validation. And we're actually working on a publication that kind of covers all of these topics. We'll be publishing that soon, but today we're going to be focusing on one of these. So one of these areas is requirements. And in digitalization, it's not just about a move from paper-based processes, although some people manage requirements using physical forms, but it also includes the use of documents and requirements to manage spreadsheets and documents to manage requirements. So the issue that you often run into here is that you'll share via email that spreadsheet full of requirements, and you might have a user that maybe loses it, or it gets buried in the inbox, or they delete it accidentally. In other cases, you send that maybe to 2 other people, and simultaneously or concurrently, they send you back their modifications, and you're left trying to figure out, okay, how do we consolidate these changes back into one spreadsheet, right? So there's lots of room for error here, right? There's lots of potential delays in the process with this basic digital approach, which you want to get away from, right? And digitalization helps you get away from that. So the alternative instead is requirements are managed in a central location digitally somewhere, and everybody goes and accesses the requirements in that central repository. So they're never out of date. The tasks don't get buried, especially if there's reminders or escalations around tasks and approvals. So this helps accelerate the process. It helps remove error in the process. And this approach alone, this centralized requirements management, can be incredibly powerful in improving the process. Another area here, and again, we're focusing on detailed design. Another area that we can talk about is design modeling. So many times you have to deal with foreign data or data that comes from another CAD solution. You got to remember, in the supply chain, not everybody is going to be using the same tool. So you will often need to exchange designs back and forth based on designs that don't come from the tool that you use. And then there's also scan data. This might come from a reverse engineering effort, might come from a topology optimization effort, might come from a finite element analysis. But you need to be able to tweak and modify and change that representation of the design. So with parametric modeling, there aren't a lot of good ways to do that. Parametric modeling kind of relies on the fact that you have features, and those features have parameters and dimensions, and that's how you can change them. Well, what happens when you don't have access to those features, right? So this is another area that where improvements can be seen. And the enablers for these improvements, one is direct modeling. And what this lets you do, even when there are no features there, lets you grab geometry directly and push and pull or transform it in some way. Furthermore, this can be enabled with facet modeling, where if you're dealing with mesh geometry, where there's not even smooth geometry for you to manipulate, there's this concept of facet modeling where you can modify that and tweak it and push it and change it and this means you don't have to put in the effort to remodel it using parametric approaches. So this is another front on which you can use different approaches and be more efficient. Another area that we can look at is legacy. Legacy deliverables. And if you're in a company that has been a supplier for any amount of time, you will want to go back and reuse designs from past projects. So sometimes those deliverables come in the form of 3D models. Sometimes they're just 2D drawings with 2D entities, and there is no 3D model associated with it at all. So the issue that you run into here, often in using traditional CAD tools, is that these legacy drawings often will have hundreds, if not thousands, of entities. So sketching tools like to, let's see, how do I say it? They like to fix the location of every entity and then allow you to change it. So there's this solver in the background that's figuring out, okay, where is every single 2D entity on this drawing? And with big drawings, that can bog down dramatically. In some cases, in huge drawings, your CAD tool will become unresponsive. That's a problem, obviously. The other issue here is that when you have a legacy model that was used, maybe used parametric modeling, maybe used another approach to build it out, but after 5 years, 10 years, 15 years, the version of the software used to build that model might no longer be available, and the geometry that was created might no longer be modifiable, even with the latest version of the same software you used to design it. So this goes back to the same situation as before. It's almost as if it was a foreign model, or you imported it from somewhere else in a neutral format. Parametric modeling approaches do not help you in that regard. So what do you do here? Well, there are new technologies that can help. One is direct sketching. Direct sketching acts a lot like direct modeling, except that when you have so many entities, its solver will look at the minimal number of entities it needs to solve for the entities you want to modify. So the scope of what it is solving is very, very limited. It's not looking at the entire drawing. So this actually makes it far more productive. It makes you able to modify these drawings very quickly and easily, even when they have a huge number of entities. And with the 3D models that are legacy models, direct modeling is a great solution here. Again, you can push and pull on geometry, same sort of thing before, but very, very powerful. Another front to look at is not just the mechanical design stuff, but also the electrical stuff. So in this case, you want to make sure that the representations you have for electrical designs, whether they're electrical systems like wire and harness, or even circuit boards, you want to be able to collaborate and share and exchange the latest design changes with mechanical design representations. And for electrical systems, that means routing the wiring through your 3D assembly. For board systems, it means passing over a layout and then creating a 3D model from that layout to check for things like interference with the enclosure, to check for even running cooling analyses using fluid dynamics. So how do you do that? So the traditional approach has been file-based exchanges. You can, IDF has been going through some changes. It's actually been getting a little bit better. But exchanging files and importing them and going back and forth is a manual effort that requires explicit and conscious effort by the engineers involved. So what often happens is that it's done early on, kind of doing a first check, but then it's skipped a lot until the very end of the development process. And the reason why this is kind of an issue is because if you're waiting until the very end of development, especially with wiring systems, they tend to be delayed and not seen as on the critical path. If you delay that to the end and you uncover an issue because you haven't been continuously validating or verifying, that can throw a big delay in the overall development schedule, especially the design release cycle. So this is an area where improvement is needed. So the alternative here is being able to synchronize tool to tool or application to application between the ECAD solution that you're using and the MCAD solution that you're using. And the idea here is that there's no file explicitly being exchanged. The two applications are communicating directly back and forth to one another. So what this enables you to do is very quickly and easily update each other with changes continuously throughout the design cycle. So this allows you to avoid this issue of waiting until the end of development to pass changes back and forth. So this is another powerful capability that can help with digitalization. So that's my part of the presentation. And at this point, I'd like to pass it over to David Chadwick.
Okay, thanks, Chad, and thanks, Jake. And it's good to be able to talk to you today about some of the challenges faced by aerospace supply chain companies. And in this section, we'll talk a little bit more detail about some of the solutions that we have to help manufacturers in this area improve their performance for product development. Okay, and I guess the first message that we have is this idea that Chad has already referenced, the idea of companies undergoing a digital transformation. As we've seen in the past, some companies that haven't seen the opportunities of digitalization have really become extinct. And from a Siemens point of view, one thing that we offer is a full closed-loop digital twin of your entire innovation process. So from concept design through to detail design, through to how do you maintain the piece of equipment or the products that you design in practice as well. And the way that we do this is through something called the Siemens Digital Innovation Platform, which has solutions in all areas like mechanical design, electronic and electrical design, simulation, and then all the way through to the manufacturing areas as well. But one of the questions we often get asked is, this sounds like a lot to take on board for manufacturing companies. Is this really practical for small and medium-sized manufacturers to create a digital twin of their product and to use it throughout the whole product development lifecycle? Smaller companies, they might not have a large IT department, they might not have the budget to invest in complex product development software. But what we do is we offer a portfolio of solutions which are really targeted more at these small and medium-sized manufacturing companies. So our answer to that question is very much yes, that small and medium-sized manufacturing companies can very much participate in this idea of digital transformation. In fact, we ran a survey just last year, with a company called IDC, asking small and medium-sized manufacturing companies on their views of digital transformation, whether they were investing in this area right now. And the results, I think, were quite surprising in that we found that over 90% of these companies were already allocating budgets for digital transformation. 50% of them already have dedicated staff in this area, and 46% of them reported that digital technologies are already enabling them to better compete with larger companies. So we very much see this idea of digital transformation does level the playing field for these smaller companies and actually enables them to disrupt the industries that they're operating in. One of the questions we asked them was what they saw as their goals for implementing digital transformation. And the two areas that came out top were improving their overall product development process and, more specifically, improving their design process. So more than 50% of the respondents saw these two areas as key areas where they thought that digital transformation could really help them improve their own productivity. So we believe the foundation of digital transformation is this idea of creating a detailed 3D digital model of your product and then using that as the basis for all areas of product development. So this could include, for example, managing customer requirements, going through concept and detailed design, prototyping, simulation, manufacturing, installation, and service. So the digital twin is something that you create and you add intelligence to as you go through all these phases of product development. It becomes richer as you go through all these steps and becomes more intelligent as you go through all these steps as well. So let's look at some of the key processes that aerospace supply chain companies need to go through and some of the areas where we can help them improve their productivity for product development. So in this chart, we show some of these key areas. For example, starting in the top left-hand corner, the ability simply to visualize new products. So create rendered images, so photorealistic images of the product to use in the sales and marketing process, but also just to communicate the value of your designs to prospective customers is very important. Chad mentioned the importance of managing requirements throughout the product development process. So being able to manage both customer requirements and also compliance with industry regulations we see as key processes as well. One particular area we see that is important for aerospace supply chain companies is the ability to reuse customer data. So this data, maybe you're designing a tool which is used to fit a particular part of the airframe. You would need the model of that particular component, and it might be in a third-party CAD product. So your solution needs to work very well with data in many different formats. Then we have the very fundamental area of speeding mechanical design, both from a 3D point of view, but also being able to create 2D drawings and consume 2D engineering drawings is still very important. And then some of the more specific mechanical design areas that we see in use in the aerospace supply chain industry, developing sheet metal housing and guarding can be very important, or even components and products which are made largely out of sheet metal. And then being able to develop weldments and fabrications as well. So your CAD solution really needs to support these areas very well. The ability to integrate electrical components into otherwise mechanical assemblies is becoming increasingly important as well. And And then being able to validate your products using virtual prototypes. So here we're trying to reduce the amount of physical prototypes that you might need to manufacture and test, do more of your validation in the virtual environment. It's faster and more accurate as well. And then, of course, going through to manufacturing, being able to manufacture your product accurately and efficiently. How does your CAD solution support that part of the process? We already mentioned compliance with industry regulations. Being able to collaborate better with suppliers and customers as you go through the product development process is also key. And then going all the way through to servicing and maintaining your product as well. For example, are you producing really good graphically based maintenance manuals for your products, which will help ensure that your products are maintained correctly when they're in service, is very important as well. So we see that companies in this area are looking for professional software solutions for product development, but especially as we're talking a lot of smaller companies here, the affordability of these solutions, the ease of use of these solutions, and ease of access is very important as well. And when we're talking about aerospace supply chain companies, our view of this is really very broad. So I guess the primary area we tend to think about is these Tier 2 and Tier 3 aerospace supply chain companies. So companies that are supplying components to larger aerospace supply chain companies. An example would be this jet engine you see here. A company, one of our customers right now, supplying components for jet engines. But we also see tooling manufacturers and departments in larger aerospace companies that are creating tooling as an important area for us. Project-based aerospace contractors as well, somebody who has a specific project, maybe to design a device that's going up into space. Startup aerospace manufacturers is also an important area for us. We have an excellent program for getting free software to startup manufacturers. Also, companies that are involved in aircraft refurbishment and companies that are involved in design and manufacture of the ground support equipment that you see at airports as well. So our view of this area is not just for companies that are purely in the supply chain, but a lot of diverse manufacturing companies. And the solution that we're going to talk about in a bit more detail now is called the Solid Edge portfolio. So as you can see here, the Solid Edge portfolio is also a pretty broad set of solutions that support the whole product development process. So you can see the pillars of our solution here, starting with the mechanical design area, but also covering the electrical design area as well, and then going into the simulation and manufacturing areas, creating technical publications. Data management is very important. All those previous pillars can create a lot of information, and being able to manage that in a efficient way is very important. And then having cloud-based solutions like our portal, which allows you to share your data in a controlled way with customers and suppliers, is very important as well. So today, because we have limited time, we're just going to focus on a few of these areas, the ones highlighted in purple here. So the first one I want to talk about in a bit more detail is this idea of being able to manage customer and regulatory requirements as you go through the product development lifecycle. And one of the keys here is we see that customer requirements typically come into your company from many different sources and are supplied in different formats. So you might have a PDF document, you might have Excel spreadsheets, you might have Word documents. So a lot of different formats, and typically a lot of time and effort is needed to manage these documents. And in addition to customer requirements, it's important to keep track of how you're meeting regulatory requirements as well. there's certainly a risk to your business if you don't have a good process for ensuring that as you go through the product development process, you are always looking to meet customer requirements and regulatory requirements as well. Now, a solution we have here is a very easy to use tool for capturing these customer requirements that come in from many different sources and making them really very visible to the designers and everybody working on the product as you go through from concept design to detailed design all the way through to manufacturing as well. As you can see in the top right here, we actually have a panel displayed alongside the CAD model. So as you select different parts or sub-assemblies, you can see the requirements that you have captured that are relevant to those particular parts. And another component of this, something that Chad mentioned earlier, this idea of electronic workflows for controlled and consistent process completion as well. So we believe by implementing these type of tools, you can really reduce your business risk by ensuring that customer and regulatory requirements are visible to everybody and tracking how and when those requirements are met. And this is a quote from one of our users of this particular solid requirements management capability. This company is Aero RD, a small, more R&D based aerospace company. They saw that collating product requirements from many different sources was a real issue from them. And they really like this idea of how Solid Edge Requirements Management gives them a tool to collect up all those requirements and have access to them directly from their design software. The next area I want to discuss is reusing customer data. So as I mentioned, in the aerospace industry, a lot of the big aerospace companies may be using high-end CAD solutions like NX and CATIA, for example. So you need to be able to work with that data very easily. For example, if you're designing some of the tooling, the jigs and fixtures that are shown here, which are helping with the assembly or maintenance of an aircraft, you need to design those in the context of the airframe itself. So Siemens is very much a leader in supporting open standards and has really good tools allowing you to bring in data that was originally created in different CAD formats and work with that data. We can even recognize a lot of intelligence in that data. So that if there are features in that original CAD data, for example, a specific hole type, then we can really recognize that as a feature as we bring it into the Solid Edge environment. So this idea of being able to incorporate third-party CAD data into your product development process, we see as one of the keys in the aerospace supply chain area. The next area we're going to discuss is speeding product design and focus here on the mechanical design. So if you like, this is the core of what 3D CAD systems have done for a long time. We believe we have a very comprehensive solution here that can really help you speed the design process. We have some very nice technology called synchronous technology, which allows you to develop products very quickly. It's very flexible how you can make changes to the product as you go through the design process. So that will help you make changes in the future if you need to change your product to meet a particular customer requirement. And as I mentioned earlier, it also has a lot of intelligence built into it. So if you want to base your design on a previous CAD model, whether it came from a third party or your own system, then you can have immediate access to that and all the intelligence in that model as well. One area we've been working on recently is kind of broadening our capabilities and for the design process. So we're not talking about the traditional 3D CAD modeling here, but adding in new capabilities, and we refer to this as next generation design, For example, the image you see on the top left is an example of generative design. This is where you apply computing power to the design of components. You just input some parameters about the component that you want to model, where the bearing surfaces are going to be, what is the envelope that it will fit into, what are the loads that are going to be applied to it, and the system really goes away and produces these organic looking models which are really optimized to be strong and lightweight components. Reverse engineering we see as being very important as well, the ability to scan existing 3D parts and bring those into your product development process. And this is all enabled by something we call convergent modeling, and this is bringing together the traditional 3D CAD formats, which are typically the underlying mathematics there is boundary representation models, and the results of these other processes convert generative design and reverse engineering, which are these mesh-based models that Chad was talking about earlier. And then how do we output our models for additive manufacturing and for applications like augmented reality and virtual reality? Again, we're using convergent modeling here to supply accurate models to these downstream applications as well. Another tool that you can use in this area, this core area of faster mechanical design, is something called the Solid Edge ROI calculator. So if you just do a Google search on Solid Edge ROI calculator, you'll get access to our online tool. Here you can enter some parameters about your business, how many designers you have, how many design projects you do per year. And then you can get an illustration of the time you can save for completing design projects using our software. And this is based on metrics that we have from existing customers. So we have customers who've seen that they can speed up the design process, for example, by 10 or 20% or even higher. So we've taken those metrics and put them into this tool so you can get an example of the type of time savings that you can achieve. Alongside the ROI calculator, we have a more detailed support document which talks about the different areas where we believe you can achieve advances in your productivity. For example, faster design of new products, faster re-engineering of existing products, and you can see some of the other areas that where you can improve your productivity here. So if you're interested in that, you can access the ROI tool online, and you can also see some specific examples and quotes from customers of the types of time savings that they are achieving. Next area I want to touch on briefly is this idea of combining electrical and mechanical design. As Chad mentioned earlier, we see increased complexity of products, including, for example, increased use of sensors, actuators, and motors. So this in turn drives the need for more electrical components in your designs, more wiring in your designs. We have a really nice integrated solution here. So we have applications for fast creation of 2D wiring schematics and wire harnesses, the ability to bring the data from those applications into your mechanical assembly models, route the wires, calculate the exact wire lengths, and then send those back to the electrical applications. Within the electrical applications, we simulate the circuits, so we detect things like short circuits, and you can make sure you get the correct wire gauge and fuse sizes as well. This is just a schematic of how these products work together. On the left-hand side, you have our wiring design solution with this integrated simulation capability. On the right-hand side, the harness design solution. And we use something called a connected mode of operation to exchange data to and from the Solid Edge 3D CAD environment. Another area I want to touch on briefly is this idea of increasing use of virtual prototypes. So, obviously you can create physical prototypes of your products and test those physically, but it's more efficient if you can do this in the virtual world. And we have some nice tools here built into the Solid Edge portfolio, Solid Edge simulation, where you can do FEA type analysis for static, dynamic, and fatigue type issues. We also have integrated computational fluid dynamics capabilities as well. And again, these are embedded directly into the mechanical CAD software, so you don't have to leave to a different software to do this performance. And also any changes you make to your design, you can simply rerun the analysis without having to set up the analysis again. Okay, so those were just some examples. We just took a few of those 12 key areas to focus on today. Now I just want to talk a little bit about some of the customer success that we've seen our customers achieving. So we have a number of case studies that you can access for how aerospace supply chain companies have been applying the Solid Edge portfolio. And you can see here some of the type of benefits that these customers have been achieving using this software. I'll just briefly touch on 3 examples, and these are 3 examples from quite different companies as well. This first one, Aerotech Peissenberg, they make jet engine components, so they're definitely a good example of a supply chain companies. For them, some of their challenges were around this idea of seamless data exchange with their customers, the importance of compliance for their products and documenting that compliance, and cost efficiency for their products and their product development process as well. So they have implemented Solid Edge, and you can see some of the benefits that they've achieved here by implementing Solid Edge. For example, 15% process saving times between engineering and manufacturing. Next example is a company called Indire, actually in South America. They're more in the area of refurbishing existing planes. So here, being able to reuse previous design data is very important for them, because they're really creating some new components to work in an existing aeroplane. Again, they've been using Solid Edge to achieve some benefits here. For example, they've seen an improvement in productivity of 40% for product development. And finally, this one is company TAIWAN Filin. They make ground support equipment, in this case load containers that go on aeroplanes. Might seem like a fairly basic type of product, but obviously the strength and lightweight nature of these products is very important. For them, one of the particular aspects they really like from the Solid Edge portfolio is that we have really excellent sheet metal design and fabrication tools, not just for the design process, but that output the correct data for manufacturing as well. And just one point I'd like to make is, if you're in the supply chain, Siemens software is used by a lot of the big aerospace companies. So companies like Rolls-Royce, Boeing, Pratt & Whitney, General Dynamics, SpaceX. A lot of these companies are using Siemens software. So if you're in the supply chain with them, you'll have a really good way of exchanging data with these companies. And then just a few final thoughts. If you want to find out more about the Solid Edge portfolio, you can go to our website, solidedge.siemens.com. Some of the specific materials you might want to download are listed here. And we've really tried to make Solid Edge a very easy system for smaller manufacturers to get started with. We have a free trial available. You can just download the software and start to use it for free. You can access our Solid Edge community for tips and techniques and a knowledge base and so on. We also have not just perpetual licenses, but we have subscription licenses as well. So again, for smaller companies that don't have large capital expenditure budgets, this is a good way to access and start to use our software. You can buy these online or through a local channel partner. And I'd like to just have a final mention for our Solid Edge for Startups program. So if you are a startup type manufacturer, you can access Solid Edge Premium, which is the highest level of Solid Edge. You can get free licenses for 1 year. We already have close to 1,000 participants in this program in over 40 countries worldwide. Okay, with that, I'd like to hand it back to Jay to go through the Q&A session.
So it just remains for me to say thank you to our guest speaker, Mr. Chad Jackson. It's always an honour to have you on. And of course, thank you to Mr. David Chadwick. With that, the session is closed. Goodbye.